All right, this is a continuation of the questions that you guys had from the review session today. These are some of the ones we didn't get to. So let's look at number 9. It says Charlie purchased 35 liters of gas in Canada. How many gallons did she purchase? Round to the nearest tenth. Okay, so we're looking at starting with 35 liters over 1. And we have these two facts given to us. The 1 quart is 0.95 liters and 4 quarts is gallons. So we need to go to quarts first and then to gallons. So again, I always set up my units before I put in the numbers. I need to cancel liters, so that needs to be on the bottom, and then the connection there would be to quarts. And then I don't want quarts as my final answer, so I'll need to cancel quarts, so that needs to be diagonal to that, and we'll end up with gallons. So once you have all your units labeled out, you can put your numbers in. This is the 0.95 per 1 quart. This is 4 quarts per 1 gallon. So then we're going to take our calculator and you're going to work this out. So I'm doing this off screen, so you'll need to do it on yours. This would be 35 divided by 0.95. And then we take that answer and divide that by the 4, because that's also in the bottom. And then round to the nearest tenth, we would get 9.2. And this is supposed to be gallons. Okay. For number 11, it says you're prescribed a medication with a dosage of 10 milligrams per kilogram per day. The medication is to be given 3 times a day. How much medication would be given for a single dose if your weight was 185 pounds? Now, we are going to be converting pounds to kilograms and then to the medicine and then to the dose. You almost always, when you do these medicine ones, you start with the patient first. So since the patient is in pounds and our medicine doesn't relate to that, we need to convert to kilograms first. So again, I'm going to set up my unit conversion. So I need pounds to cancel, and I'm going to end up in kilograms. So that would be 2.2 pounds for every 1 kilogram. Now, I need to get into medication. So that's where this dosage comes in. This is 10 milligrams per 1 kilogram. Again, don't worry about where these numbers are right now. Just make sure you put kilograms where it needs to cancel and then the other unit on the top. And then that would match with this. So that's 10 milligrams per 1 kilogram. And that's per day. So I'm going to write a little note there because then I want to break that up into, so this is all much medicine they would take for an entire day. We want to break that up into 3 doses. So we're going to be doing, um, for one day, they're going to have 3 doses. Okay. So that would cancel out the days. So this will be milligrams per dose when we're done. So it's 185 divided by 2.2 and then times that answer by 10 and then divide that answer by 3. Round to the nearest whole milligrams. This is going to round for me to 300, or excuse me, 280 um, milligrams. And that would be per dose. Okay. All right. So that gets 9 and 11. So we were actually trying to finish up some of the later half in class. Those two were just asked of me before I left. So let's look at number 24. It says, what is the probability of rolling an odd number or rolling a 2 if you have a six-sided die? So remember, a six-sided die is 1, 2, 3, 4, 5, 6. That's the numbers you can get. And we want the probability of getting odd or a 2, an exact 2. Okay. So when you do probability, you have to do probability of the first event when you're doing an or, plus the probability of the second event, and then minus the probability that you are both at the same time. Now, you can't be both an odd and a 2 at the same time because odd is 1, 3, 5, and even is 2, 4, 6. So 2 is not an odd number. So you do not need the subtraction step unless they overlap each other. So this is just probability of odd plus probability of being a 2. So there were 3, oops, guess I opened the footer. 3 out of the 6 numbers are odd. 1 out of the 6 numbers is a 2, so this is 4, 6, which reduces to 2/3. Okay, then we were looking at 28. This is another chart where we have the probability is going to be asked us based on how they word the question, whether it's an and or an or a given. We have to read that very carefully. But they surveyed a total of 453 people. They gave them some kind of veterinarian gave them a test. I guess these are dogs, not people, to determine if the test is effective, if they have food allergies. So they either have a disease or they don't in their body, and the test either came back saying they did have disease or didn't have disease. So positive, remember, means disease is present. So if we want to look at gives a false negative result, that's saying what's the probability that I got a false negative, given you already know the person has a negative result. So false positive and false negatives are always conditional probabilities, even though they're not phrased the way that we're normally used to. It's because you already know the result they got was negative. We're just saying it didn't tell the right story. It says it's a false negative. So you're going to be focused on just negative tests. There were 301 negative tests, and negative means you don't have disease. So there were three people out of the 301 that were three dogs that were incorrectly put into that.